Now, I'm sure you know by now that in the past decades, machine learning has really given us self-driving cars, speech recognition, effective web search, that's a fancy word for Google, house price prediction, Netflix, as well as Amazon recommendations. And guess what? That's really only the start of what's possible. Now, in this course, you are going to learn how to build powerful machine learning model to solve any problems. Now, you will go from beginner, completely novice, to extremely high level, and your instructor will build each algorithm with you step by step. Now, by the time you finish this course, you will have trained machine learning algorithm to do the following: classify flowers, predict house price, identify handwritings or digits, identify staff that is most likely to leave prematurely, and other things such as conduct medical diagnosis, such as detecting cancerous cells, segment your customers, and identify those underserved, I should say, profitable clients. And of course, much more. Now, for this course, no prior machine learning or Python experience is required. All the data sets, the source codes are available for download, and you get friendly support in the Q&A area. Now, I want you to be successful in your life and have a fulfilling life. So let's get started. Start learning and start applying everything you have learned and start solving real life problems in your business, be it your jobs or be it personal life, with machine learning algorithms. In the previous video, we went through how to download the iris datasets. And I hope you found it useful and been able to actually execute the same task yourself. So in this video, we are going to move into data exploration as well as analysis using the iris datasets that we have already downloaded earlier. So earlier I used the example of using the CMD to start the command prompt. Under Windows, there is the Windows PowerShell that you can also do likewise. It's exactly the same. So we're going to do activate our iris project. And the only problem with using this screen is that I can't see that it has been activated. So let's try. So I need to switch over the CMD, so activate iris project. And now you can see that the iris project has indeed been activated. So we're gonna cd into documents now, and iris project. And okay, we are in our working directory now. For this purpose, for this project, for this video, I'm going to use the Jupyter Notebook. The notebook directory is just going to be the current directory that I am in. We will start afresh, and we call this the iris project. Okay, and we just give ourselves the iris project. Okay, and we're going to give it the second heading, and we'll call it data exploration and analysis. Okay, some basic things that we do need to do is that we do need to import a couple of typical standard library, NumPy. We're going to make use of pandas as well, and we are also going to import Seaborn. NumPy is a numerical Python, pandas is a data frame. It's extremely powerful for data analysis. Seaborn is actually a visualization tool. We're also going to import matplotlib, pyplot as plt as well. That's really, again, a visualization tool. We're going to set our just play some settings. Code is equal to true, and finally we're gonna plot our chart matplotlib inline. Okay, as panda. As it's running, it shows a star. Once it's actually finished running, it shows a 2. Let's import our dataset. I'm just going to call it data frame is equal to the beauty of using pandas is that you can just read the CSV and iris.data. That was our file name. Okay, so let's see if it's been imported successfully. We're gonna read the first 5 rows of data, and the first thing that you notice that something is not quite right. You notice that the headings is actually in the form of the data itself. So it looks like we need to re-import this and change it to the headings. Okay, so how do you actually import that with the understanding that the first row is actually already a data rather than a label? So we're gonna use the pandas .read CSV and just show you how to actually do this. Header, we need to actually change the header portion, so we're going to change that. First of all, we do need to actually specify .data. Okay, so it requires an import as 0. Okay, -1. So it requires a -1. So now that it's -1, then it's imported correctly. Now the first row is actually the data. Okay, so now we're gonna store this into our data frame. PD read. Okay, and we're gonna just show the header. And notice that it's been imported correctly. That's not really satisfactory, however, because quite often we want the actual label to be done correctly. Right now, what do we need to do? We need to actually go back to the actual data set itself and have a look at this and look at the so-called labeling. So you can see the first column is the sepal length, second one is the sepal width, petal length and petal width, and finally the class itself. So this is what we can do, is you can column names, come over here, and we just can copy and paste this over and store this as a list. And just repeat for each and every one of those label. Fortunately, someone has already done this exercise for us, but I'm doing it the hard way because quite often what you will find is that a big part of your job, when you actually, before you can even start the data analysis itself, you do need to actually do this exercise. So, okay. Now, one of the beauty of using the Jupyter Notebook is that you can actually tab and scroll through the list of different names, different so-called properties that you can actually change to. So let's see if this works. df head, no. Okay, right. What you can see now is that you can see that our column headings has been labeled properly now. You have sepal length, sepal width, petal length, and petal width, and finally the actual class itself. Having done all that, I'm gonna leave that. That's really to show you that a little bit of the data cleaning. I'm just gonna import the iris dataset directly from the Seaborn database. Now, the reason is that, as I mentioned previously, the iris dataset is very popular. So a lot of these libraries has already preloaded these data onto their so-called library so that you can actually quickly make use of and start your analysis. So I'm going to call this iris, and using the Seaborn, which already have the so-called dataset imported. So I'm going to load that and view this. Seaborn also preloaded it as a pandas data frame as well. So as you can see, what you have is that sepal length, sepal width, petal, so all of those are exactly the same as the label. It's just that the iris dash has been tidied up, some of the data has been tidied up. So what we want to do now is just do a quick analysis. Counts, nope, describe. The datasets that we downloaded has 150 entries. So let's look at the one that is actually in the Seaborn database. It's also 150. So for all intent and purpose, the datasets are exactly the same. There's some slight variation in terms of the sepal width. Other than that, the petal width is also slightly different as well. The beauty of using pandas is that you can actually use these so-called shorthand method describe. You can see that the sepal length has a mean of 5.8. The standard deviation is of 0.82. The min is 4.3. The max is 7.9. And you can see basically the actual general so-called data description. This is a really quick data exploration exercise just to actually get a feel of your data. Notice the range are quite different. The petal width are actually quite small. So when you're actually performing analysis, there may be a need to actually start to normalize this. I'll come back and explain normalize, what normalization is, or min-max, scaling it in future video, but this is just to actually get you appreciation of the fact that the data range, scale, or size are different, so it's going to have an impact on your analysis. So it's almost always a good practice to actually normalize your data automatically. Okay, so the next thing that we're going to do is just print the actual data set, the so-called iris info. Let's see if there's any info that's been stored. Okay, there are some info being stored. So there's 150 entries. There are multiple columns. So the first four that we looked at, well, there's 150. These are float. The last one is actually an object. And we want to just also have a look at the, we've already analyzed the four so-called continuous variable, so which is the sepal length, width, or petal as well. So we already know what they are. Let's have a look at the iris, and we're just gonna do a little bit of group by, and based on the so-called species, and we look at the actual size itself. Okay, so looking at this, we're grouping the so-called species type, and we can see that the actual size of these are 50 each. It's actually a pretty so-called even database that allow us to conduct our analysis. So for now, that's pretty much the end of this video. Before we move on, I'd like you to try this exercise yourself. Play around with the Jupyter Notebook and explore the iris data. One thing that you can do is, instead of printing just the head itself, the first 5, can you print the whole lot, look at all the data itself? Can you actually conduct your own standard deviation calculation? Just try this exercise. I'm going to pause the video and let you actually play around with this. I would really strongly encourage you to play with it. The more you interact with the datasets, the more intuition you will be able to develop, and that will actually aid you further down when you try to actually conduct your machine learning or your modeling of the data, trying to find a way to represent the real world. that's really the whole intent of the exercise, is to get a feel of the data, develop intuition, and try to model it and also predict going forward. What we've done so far is just to perform a really quick analysis of our data, just to explore, get a feel of it. What kind of data do we have? Are we dealing with numerical data? Are we dealing with text? Are we dealing with strings? What are we dealing with? So the whole exercise here is to get a feel of our data, and always at the back of your mind, think of what are you trying to achieve here. So for now, we're going to stop this. In the next video, we're going to do some presentation or data visualization to actually get a much more in-depth view of it. So at least for now, we have some range. We can see the range of our data. We can see the categorical data. What are we dealing with? We have 3 different data categories or flower types. And we're going to move on to a little bit more in terms of the presentation in the next video. Right, welcome back. In the previous video, what we've gone through is the exploration of the data. We did some preliminary analysis of the data, get a feel of it. But to progress further and to dive into the data a little bit more, we are going to do some visualization. Visualization is a great way to develop a better understanding of your data, and Python has a lot of great tools for specifically that purpose. So let me just label this visualization. And we've already imported the seaborn, so we just have to perform the pair plot and using the iris data sets that we have. The hue is the species, and we're just going to set the size as 1.5 and close that off and run that. Now this is a tad small. Let me just change the configuration a little bit. So what I did is that I've changed the size to 3 and I get a much larger picture. So previously what we had was 1.5, and 1.5 is actually a little bit squashed, so we can also switch to 2 to get a slightly better visual of it. I think 3 is just about right. So what does this picture actually tell us? And if you look carefully, what you can see here is that you have the sepal length, and then you have the sepal length. You have the sepal length versus the petal length. So if you look at the different species of flowers, you have Setosa, versicolor, and also virginica. The Setosa has pretty short sepal length and also petal length. The green one is versicolor, has slightly longer sepal length and also petal width. And the virginica has even longer sepal length and also petal width. So this, you can see that there are actually some really clear distinction here. Along this part is actually the petal width with the petal width, so it's not so informative. But you can clearly see that there are some very distinctive relationship and also characteristics of each of them. So Setosa is actually quite distinctive on its own. It has pretty short petal length, and also the sepal length is by itself, it actually is pretty short. Let me just do this visualization a little bit. So let's look at Setosa flower. So let's just look at the images. So this is what the 3 different types looks like. Although they look really similar, let's open up. Okay, let's go and look at the image itself. Okay, let's just blow this up a little bit. You can see that Setosa has this, and they all individually has very distinctive characteristics, and by visualization you can immediately tell that Setosa on its own it really stands out, very distinctively different. Whereby versicolor and virginica is actually very similar. There are some variations, but in terms of the sepal width, it's very similar in terms of length. If you look at the sepal width, again, they overlap a lot in the sepal width side. How about the sepal length? It's also pretty similar. The pedal part is what distinguished the two of them. In terms of the pedal width and length, in fact, you can see that the versicolor has shorter width and also shorter length, and that's although there are a fair bit of overlaps as well. So that's the power of visualization, is to allow you to actually very quickly visualize and pick that out. Now, the next thing that you really want to do is actually conduct a little bit of distribution plot. That's one of the way to actually quickly get some intuition. Is equal to, let's just use 1.2. This is plotting the historical, and we're gonna use the. Let's just plot this and see what it looks like. Let's show. Yeah, and I'm not too sure if we can set the size to equal to 3. Let's just bring up the documentation and see what is available for us to set. Yeah, so it doesn't actually have the size that we can control. Fixed size, yeah, maybe we can actually just use directly fixed size. Fixed size is equal to, let's say 12.8. Okay, we can directly control it via that way. And through this, you can also see some very distinctive difference between the actual flowers itself. This is basically the pure distribution of all three combined, and from this it's not really all that informative, because it just tells you overall what is the petal length distribution. You have from 1 to 7, petal width is from 0 to 2.5. We can already see this from the earlier described output here. But what we really want to do, I mean, of course you will do these preliminary steps to actually get the distribution of it, just to actually see what is the normal distribution. The next thing that you really want to look at is the, okay, by species, each species of the so-called flowers, are they quite different? Let's do a subplot. And have a look at what it looks like. We just used one of the violin plot of Seaborn, and we're just going to use the species, and we're just going to label Y as the so-called petal length, and we have the data is equal to iris. Let's repeat this. Okay, so we're looking at the second one, the third one, and the fourth one. Okay, so alright, I need to actually take these, proper label over. So I need the sepal length. Actually, it's not petal, it needs to have an underscore, and it's all small caps. So let me just bring that over. Let me bring that over as well, and finally let me bring that over, and that should gives me the full plot. 1 2 3 4 5. Let's run that and see. Okay, shift enter to run. Okay, cannot interpret the input sepal length. Okay, I think there's just that space there, so let's just plot that out. Okay, so it's a bit small, so let's just change the figure size. So in order to change the fixed size, what we have to do is make use of matplotlib. Figure fixed size is equal to, let's just use 12.8, and we just run this and see if it actually cooperates with us. Okay, that's fine. Okay, so that's the right size. So looking at this, let me just, I really don't like the noise. Yeah, okay, so looking at this, what kind of conclusion can we draw? You're looking at the sepal length. You can see that the distribution is clearly shorter than both versicolor and virginica. Virginica has much longer in terms of distribution. The average length is longer than the versicolor. Looking at the so-called sepal length, what can we draw in terms of conclusion? The sepal width of Setosa is it has the widest distribution and also the longest sepal width as well compared to the other two. Setosa has the shortest petal length and the shortest petal width, while the other two is very similar. Virginica has pretty much slightly longer, but fairly a lot of overlaps with versicolor. Now, the other way that you can represent the data is to use the box plot. Box plot is actually very similar to the Violin plot. So we're just going to use species. Wait a sec, needs to be properly labeled as a text, and fixed size is equal to 12, 8, I believe is what we use. Okay, so notice that it's actually a very similar representation, although it actually did a flip. But the one difference is that with box plot, it actually used the same scale, whereas Violin plot used a slightly different scale for each categories. So with it does actually highlight slightly different things when you use the same scale. You can see that definitely the Setosa has much shorter petal width and length, and clearly. Right, and also the other thing that you can see here is that the flowers all have longer length and much shorter width. Okay, just along the the visualization, I just want to highlight another possible plot that you can use under the so-called Seaborn. It does have a scatter. Does it? No, I think I might have to use pandas. Scatter plot. Yep, scatter matrix. Iris and fig size is equal to 12, 8, and we just plot it and see. Okay, so has no show. I'm sorry, grumpy. Okay, so looking at this, okay, it's deprecated, so you need to use plotting. Okay, right, plotting scatter matrix. Okay, that's better. It looks happier now. The only problem is that this looks a bit squashed. Let's use a okay, and well, this is not as clear, not so obvious when you look at this. I think I prefer using Seaborn, which I can get a lot more, visualize a lot better using the pair plot rather than using the scatter matrix. Now, obviously, you can actually do a lot more. I think that's pretty much where I'm going to stop when it comes to the visualization video here. Now, what I would really like you to do, having demonstrate to you the different types of visualization that you can do, I'd like you to actually try your hand with this. Please go through the step-by-step, vary some of the parameters, like what happens if I change the line width, what happens if I change the figure size, can I change the edge color to some other color so that it's might be aesthetically looks better, or even study the so-called plot itself and see what you can do. And if you want to, you can actually download another data set and play with it. So at the very least, just take the next 10 minutes I'm going to pause the video. Of course, you please do pause the video, and for the next 10 minutes, run through at least what I've done, type in the codes and see what actually, and study the data, see what you can actually learn from it. So I'm going to pause right now to give you a chance to actually pause the video, and when you come back, I'll speak a little bit more. All right, welcome back. So did you manage that? Now I hope that went well. Okay, again, these codes are available for you to download and allow you to actually compare it. So in this video, what we've learned is how to visualize our data and interpret it. And the reason that I really want you to actually master this part is that visualization, presenting your data, is the very important, the beginning part of your analysis to help you develop intuition, and also at the end of it when you actually present it to the stakeholder. So that's pretty much the end of this video and also this section. In the next section, we are going to start moving into the topic of regression. We're going to start to do our modeling using regression. So I look forward to seeing you in the next video.